light is made to is passed through a prism, and when it is obtained on a screen, we see a band of 7 colors VIBGYOR, which is visible light, and it falls under the spectrum of visible light, and its ranges between 4000 Armstrong and somewhere ends near about 8000 Armstrong, right? This is visible light. Now, another important thing about this visible light is that it is a continuous spectra. Continuous spectra means it starts from 4000, and then after that we get 4001 wavelength. The next wavelength is 4002. The next wavelength is 4003, 4004, 4005, 4006, 4007, 4008, 4009 and so on. So that is why it is called continuous spectra. Not a single wavelength is missing in case of dispersion of white light and when it is obtained on a screen. So this is the reason we don't see 7 colors. Actually there are innumerable colors. Okay. If you talk about red light, okay, so the red can have different shades: orangish red, fiery red, magenta red, even blue can be dark blue, navy blue, all these colors. Why is it so? Because with every wavelength there is a little bit of shift, okay, so there is a change in color. 4000 Armstrong and 4001 Armstrong would almost have the same color, but it is going to differ a bit because the wavelength is different. So slowly, that is why there is a transition of colors. This is the reason from violet it changes to indigo, green, and finally ends with red. But there are no 7 colors, there are many colors because there are many wavelengths present, and with every wavelength the color changes at a very minimum level. Okay, that is why 4001 and 4002 are definitely different wavelengths, but since there's a just difference of one wavelength, that is why they appear to be same, but maybe there is little bit of change. That is why there is a transition, right? So slowly they change. Okay, so this is called continuous spectrum. But in case of emission spectra, what happens? In emission spectra, when you heat any gas, let's say electric current, and it emits radiation, right? Even it would emit radiation, and on being passed through a prism, these rays are obtained on the screen. What do we see? Unlike the continuous spectra, in case of the white light, the wavelengths obtained, or the rays, the wavelengths which have been obtained on the screen are not continuous, they are discontinuous. Discontinuous means, suppose 4001 wavelength is there, 4002, 4003, 4004 wavelength won't be present. Discontinuous. Serially they are not going to be present. Few will be missing. Specific wavelengths could be found. And they can be visible, they cannot be visible, because as we all know, the visible ranges between VIBGYOR, right? Violet to red. It can be lesser than 4000 Armstrong. In that case, it will not be visible. It can be greater than 8000 Armstrong. There are UV rays, ultraviolet rays, X-rays, gamma rays. So they won't be visible. But one thing you will be, you need to assure yourself that this is discontinuous spectrum. All wavelengths are not obtained on the screen. Few are missing. So this is discontinuous spectra, and this is emission spectra. So what is emission spectra? As you already know, a gas is heated and a few radiations will occur. Obviously there will be radiations. The gas will radiate energy, wavelengths, certain wavelengths, and these wavelengths when obtained on the screen will, what can we see? Few specific wavelengths can be seen, which will be discontinuous, means serially they won't be present. But what is the reason behind emission spectra? Well, whenever we heat any gas, the electrons also gets excited, they get heated, and they jump from their lower energy level to their higher energy level. So when they do that, they cannot remain in the higher energy level for a long time. They are very unstable. They don't want to remain in the higher energy level. They want to get back to their ground state again. So when they get heated, they go from there, they travel from there, jump from their ground state to their higher energy level, but they want to get back to their ground state. So while returning from higher energy level back to their ground state or their present lower energy level, they emit radiations in the form of electromagnetic waves. These radiations, they are emitting radiations. These are those emissions, and this is called emission spectra.